domain concept. What is domain concept? Let's go in detail. So here in ferromagnetic also they are made up of atoms, right? Okay, but here also what will happen is that they will usually, why is the difference is that the in ferromagnetic material usually atoms have very strong magnetic moment, but they are at less energy, right? Or individual atoms do not have enough energy to overcome each other attraction of this magnetic moment. It's like, suppose you have a magnet here and you have a magnet here, small magnet, you have a magnet here, NS, this is north pole, south pole, north pole, south pole. Now they can have, individual magnet may have energy and they can be attracted by a force that also is a form of energy. They also be attracted by force, right? In case of paramagnetic material, this force, okay, force is the force energy is less than the individual is paramagnetic, right? But in case of ferromagnetic, what happens is that the force between this small magnet is stronger than individual energy, right? That's why what happens is that the effect of surrounding atoms they cannot neglect. Okay, so even though these also have slightly random magnetic moments, but what happens is that they randomly, but their force of attraction is very high, and because of that they get transformed. How they transform? They will make themselves in certain domains, something like this. So now here, 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 here. Okay, so they will form some domains where the nearby atoms they will tend to have a direction. So here is one domain. So suppose like this, right? Something like this. Okay, here also a domain, right? These domains. So these domains. Okay, so these domains also can be, these domains also can be used for paramagnetic. Okay, now this, because of this domain, now you see every domain have a tendency that these magnetic moments are aligned in the same direction, right? Now they will again get transformed. How they will transform? They will become like this. Okay, so we will now divide these domains such that, okay, now these four atoms, now they will have similar direction, so they will have a net magnetic moment. Now these four atoms they will have a net magnetic moment. This they will have a net magnetic moment. They will also have a net magnetic moment. Okay, they will have a net magnetic moment. An individual domain will now affect its domain. At first atom will affect each other. So in case of paramagnetic, these domains they cannot affect each other. In case of paramagnetic, let me draw it. So this is para, this is ferro. In case of para, what happens is that this, even these domains, the net magnetic moment they become random, so there is no net magnetic moment, right? But in case of ferromagnetic, all of them are aligned, so you will get spontaneous magnetism. Means even if you do not do anything or you do not decrease temperature or something, still get magnetic field H. So what is the ferros? And this is para. Ferros concept is they have spontaneous, in case of ferromagnetic material they have spontaneous magnetic field, means outside they can have. Okay, but in case of para they do not have spontaneous.
Oi.
magnetic field. Okay, so magnetization, magnetic property can be induced by decreasing the temperature or number 3 by applying external magnetic field. It's meaning, suppose you have this is a paramagnetic material, right? But now you apply magnetic field in this direction. So what will happen here? So everyone will be aligned in this direction. So you will have a surplus of magnetism. So if you apply here, suppose 50 Gauss, here will be suppose 65 Gauss, right? So they will add up a little bit. But in case of ferromagnetic material, they have spontaneous magnetism, do not need external magnetic field to have magnetic property. Correct? Do not need external magnetic field, but there is another thing. What thing? They are magnetic or permanent magnet at room temperature. But if you apply, these are aligned magnetic moment, right? Now if you apply temperature, okay, you increase the temperature, what can happen? This individual magnetic moment, they can absorb this energy from the heat and they get random. Okay, now if you increase the domain magnetic moments tend to be random, they become random. Okay, above a certain temperature, right? Above a certain temperature called Curie temperature. So the definition of Curie temperature is it is the temperature above which a ferromagnetic material behave as paramagnetic material, or you can say it is the temperature above which it is a temperature below which a paramagnetic material behave as a ferromagnetic material. Okay, so today's class we will stop here. Thank you.